of constitutional isomers. So, constitutional isomers have the same molecular formula, but they have different structural formulas. Ang molecular formulas only tells us pila ka carbon ug hydrogen atoms ang naa sa compound. Pero ang structural formula kay shows kung giunsa pagkunik ang mga atoms. Since lahi ang connection sa atoms, mahimong lahi pud ilang shape o properties. Mao na ginatawag sila constitutional or structural isomers. Molecular formula versus structural formula. So now let's compare molecular formula and structural formula. The molecular formula simply tells us how many atoms are present. For example, C4H10 means there are 4 carbon atoms and 10 hydrogen atoms. Meanwhile, the structural formula shows how those atoms are connected. For example, ang N-butene ug isobutene parehong C4H10, pero kung ato tan-awon ang ilang structure lahi ang arrangement, mao na ang reason nganong mahimong isomers. Molecular formula versus structural formula. So now let's compare molecular formula and structural formula. The molecular formula simply tells us how many atoms are present. For example, C4H10 means there are 4 carbon atoms and 10 hydrogen atoms. Meanwhile, the structural formula shows how those atoms are connected. For example, ang N-butene ug isobutene parehong C4H10, pero kung ato tan-awon ang ilang structure lahi ang arrangement, mao na ang reason nganong mahimong isomers. Examples: butene. So let's use butene as an example. Butene has the molecular formula C4H10. It has 2 constitutional isomers. The first one is N-butene, where all carbon atoms are connected in one straight chain. So the second one is isobutene, where one carbon forms a branch. Even though they have the same molecular formula, their structure are different. Because of this, they also have different boiling points and other physical properties. Example: pentene. Next is pentene. Pentene has the molecular formula C5H12. Unlike butene, pentene has 3 constitutional isomers. These are N-pentene, isopentene, and neopentene. As the number of carbon atoms increases, there are more possible ways to arrange them. That's why pentene has more isomers than butene. We have N-hexene. This is the simplest one because straight chain lang tanan ang carbon atoms. Wala siya branches. So, imagine lang nato siya nga mura siya straight line gikan sa first carbon hangtod sa last carbon. So, wala siya kaning branch ha. Straight lang jud siya ang N-hexane. So, sa number 2 is 2-methylpentane. So, here ang longest chain is 5 carbons or pentane. Then naa siya 1 methyl branch attached sa carbon number 2. Instead nga gastrate na ay gamay nga branch sa second carbon. So, ang ikatulo nato is 3-methylpentane. This one is almost the same as sa 2-methylpentane pero ang branch is naana sa carbon number 3. So, ang difference lang nila kay ang position sa methyl branch. So, sa number 4, 2,2/dimethylbutane. So, for this one, ang longest chain is only 4 carbons or butane. Then, instead of 1 branch, naana siya 2 methyl branches both attached sa carbon number 2. So, 2 ka branches ang naa sa same carbon niya. So, sa number 5, last example, 2,3/dimethylbutenes. This one also has a butane chain, pero ang 2 methyl branches kay nasa carbon 2 and carbon 3. So, unlike the previous one, dili sila parehas og carbon nga gi-attachan. IUPAC naming. IUPAC stands for the International Union of Pure and Applied Chemistry. They created a standard system of naming compounds so that scientists everywhere use the same names. The steps are simple. First, find the longest chains. And the second, number the chain. Third, identify the branches. And lastly, write the complete name. Following these rules avoids confusions when studying organic compounds. Physical and chemical properties. Lastly, constitutional isomers can have different physical and chemical properties. These physical properties include boiling point, melting point, and density. These properties may change because their molecular shapes are different. Their chemical properties include reactivity, stability, and combustions. Although they contain the same atoms, the different arrangement of atoms affects how they behave during chemical reactions. That's why learning constitutional isomers is important in organic chemistry. Importance in agriculture and organic chemistry. So after knowing what is constitutional isomers are, ang question is, why are they important? So why do we even study them? Constitutional isomers help us identify different organic compounds. Like even if two compounds have the same molecular formula, di lang nato pwede i-assume nga parehas sila. We still need to check the structure because the arrangement of atoms can change the identify of the compound. So example, in butane and isobutane both have the molecular formula C4H10 but because different ilang structure lahi pod ilang properties ug uses. Constitutional isomers are very important in making medicines and pesticides. Sometimes, changing the arrangements of atom can make one compound more effective than another. So, scientists study isomers para makabuhat og medicine nga mas effective og safer. So, example, kung naay pesticide nga dili kayo effective, usahay ang solution is dili madugang og atoms. But i-change lang ang arrangements sa atoms para mas maayo ang performance. So to summary, everything that I discussed today, constitutional isomers have the same molecular formula, meaning pares sila og number of carbons of hydrogen atoms. And the second, they have different structural formulas, meaning different ang pagka-connect sa ilang atoms. Because different ang arrangement sa ilang atoms, mahimo pud nga different ilang physical o chemical properties. So, for example, mahimong lahi ilang boiling point, melting point, stability, or even reactivity. So, lastly, constitutional isomers are very important because they are used in organic chemistry, agriculture, medicine, and many industries. So the main thing to remember is this. Same formula does not always mean same compound. The arrangement of atom is very important because it affects the properties and uses of the compound. That's the main idea of constitutional isomers.